Okay, now let's try to plot another graph that shows another kind of relationship between the x and y values. Okay, so this table is from your textbook, page 265. What it shows is what the time versus how many bacterial cells are present when you're maybe in your growth medium, right? So if healthy bacterial cells are grown in a freshly made growth medium, what do you expect to see? They will adapt to the environment, they will start double. They'll start duplicate, right? If you start out with maybe 100 healthy cell at the beginning, okay, and when they get settled and get adjusted, after 1 hour, it seems like the number doubled, right? And the 2 hours, another double. So it's like doubling is happening, right? So that's the data trend you have. Okay, so can you plot that data on the same way using Excel? So I have that ready here. Yes, so again, at the first and second column, I entered those numbers that you just saw. Okay, the time in hours versus the bacterial cell numbers from 100 all the way up to 12800 cells within the 7-hour time span. The same way, if you maybe highlight those two columns and go to insert, okay, and then maybe ask it what graph should be the best. It's asking, maybe it's recommending you to show it as in bar graph, but I don't want that bar graph. So let's choose maybe a line graph. Okay, so yeah, I'm gonna use the line graph. Say okay, that's what you're gonna have. Okay, line graph. Okay, so that's the relationship you see. Okay, so in this case, y values are what? Number of bacterial cells, and x values are what? Those are the hours. Okay, they grew. Okay, of course you can add, x is title, and the title for the graph and trend line. So the unique thing on this graph is what? Your line, I guess connection between all those data points are not really linear. Instead, it's like a what? Kind of curved line. So curved line is a unique representation of the exponential growth of your y values. If your y value grows kind of exponentially, you typically see a kind of curved relationship between x and y values. That's what you see, right? So that's fine. So you can just enter the x and y axis. So in this case, what will be the title for the y axis? Those will be the bacterial cell number. You can enter that cell number. Okay, it's fine. And x-axis should be what? That should be the time in hour. Okay. And then the title would be what? Number of bacterial cell present? No, it may not be. Maybe. That's fine. Okay, leave it. Okay, so that's how you plot it. Then how about the exponential relationship? That's fine. So if you like the curved line, that's fine. You can just leave it as it is. But if you want to change this curved line into a linear form, can you do that by any chance? The answer is yes. If you click on this y-axis, okay, then there's an option. If you double click on this y-axis value, I just did that. So again, double click. You see this thing is showing up there. Okay, so there are options that are showing up. The options you can do on the y-axis value. Okay, so what are the options? The minimum value it's entered, and the maximum value, of course, and the horizontal axis crossed automatic. That's fine. But here, look at this option here. Can you change that value, y values, into log form, log scale form? And see what happens if you click on that. See that? Okay, so now the y values are not natural numbers. Instead, it's a log of natural numbers. It's converted. When that happens, you see the data trend is just happened. Just changed. It was a kind of a curved line. Now it changed to a linear line, right? So yeah, you can change the y natural numbers to a log number and make this kind of curved line into a linear form if you want to. Okay, so that's an option if you want to do that. And then another thing you can do is How about the trend line, the best fit line so-called? Can you have that show up there? The answer is of course yes. If you click on that plus symbol again, select that trend line option. Okay, click on that, and then if you go to that little triangle, okay, in this case, since it's a kind of curved line, instead of selecting a linear line, okay, which will be far off, you can choose exponential fast fit line show up on your graph. So click exponential, okay, then you see that these dotted, the trend line is showing up there. Okay, so that's your best fit line in this case. Okay, does it make sense? So if you go there again, trend line, make that as exponential, and then more options, you know, oops, the linear lines is showing up again. I did it wrong. Let's go back. Trend line, make exponential, okay, and then more option. Yeah, so how about those display R scale value and an equation? Yes. Okay, so now that's the equation for your trend line, okay, which is kind of overlapping with your data line, almost at 100%. So how do you know if it's 100%? Because your R scale value is 1 equals 100%, because your best fit line is just same as your data point line, which is a perfect line. So that's how you do it. If you have an exponential kind of relationship between X and Y values, that's how you can plot that graph using Excel. Okay. And then finally, what if you have an experiment like this, where you have multiple sets of maybe Y values? For example, going back to the first experiment, you treated a number of plants, maybe 5 different plants with the hormone, different level of hormone. And from those 5 plants that are treated, you measured their fruit production, right? So actually, the Y values are like this. Okay, each tree gave you those many number of fruits. Okay, so what do you do with this? Can you use some kind of statistical analysis on this data set using maybe grafting software? Okay, so the answer is of course yes, right? So this table, I'm going to plot that on Excel again. Okay, right here. So here, so the hormone level, the first column, and the next 1, 2, 3, 4, 5 columns, I entered those fruit production numbers on the Excel here. So instead of having 2 columns, now I have what? The first column is the hormone level, the independent variable, and then next 5 columns are the fruit production from the plants. Okay, so now if you have that, how are you gonna graph this? Should you have 5 different lines showing up? No, instead you can highlight this column, okay, and then click on shift and press the shift button. Before that, I'm sorry, you can maybe do some statistical analysis on these values, the 5 columns. So for example, maybe you can highlight these, okay. On the next column, for example, you can maybe enter the average of these values by clicking on there. Okay, so write down the equation, okay, equals average from where to where, from column B2 to maybe F2. So that's the equation there, to get the average of these fruits from 5 plants, right? So the average happens to be, the Excel is automatically calculating that, it's 3.8. Okay, so that's the average. Then can you do the same for these? Yes, the answer is yes. If you click on that little square there, okay, square, and then if you bring it down, it's going to automatically copy that. So all the columns will be calculating those values. Okay, so it's already done, so I'm not going to redo again. So that's how you do it. So the average can be calculated by Excel automatically, right? Once that's done, you can have, instead of plotting all these, you can just plot these 2 columns. Okay, highlight that, click, and highlight that, and control, and then highlight that, and then go to the insert, and then go to that, again, this graph I guess option, and maybe recommended graph again. So say okay. So that's how I'm gonna plot. So that's that. Okay. So that's the same graph. Okay, between these two, average and the hormone level. Okay, so now you did that average calculation on top of other things, right? Well, that's showing up there. Okay. Can you also calculate the standard deviation out of all these? Those are the standard deviation is the scaleness of these fruit numbers among these 5 plants, right? Yes, the answer is of course yes. Dedicate this column for that calculation, standard deviation, and then here, so equal, you enter the equation, equals standard deviation, and then from where to where? From here to here, B2 to B5. Okay, so that's the equation. If you enter that, yes, standard deviation is automatically calculated. Once that's done, drag that little triangle, okay, and then bring it down. Then it's going to automatically copy that equation to all these, okay, and that's how you can calculate all the standard deviation for all this data set. So not only you can enter those calculated values like average and standard deviation, your graph can show you those here. So the same way as you did before, you can enter the title for the graph by click on this plus symbol, and the title for the y-axis and x-axis. Of course, you can enter those by clicking on axis title, chart title, and all those things. And then also have the trend line show up there by clicking on that, and this little triangle, more options, of course, and you can have the equation show up if you want to. Okay, so trend line, more options. Yeah, if you bring it down, have display equation R scale value. That's how it's going to show up. So it's already done, so I don't have to redo it. So another thing you can play with your Excel is can you somehow have those standard error or standard deviation show up on your graph based on these 5 collected data from 5 different plants? The relationship between the average and all those real actual food numbers from 5 different plants. Can those be how close they are to the average, how scattered they are from the average? Can you have them show up on your graph as these bars on these data points? Okay, of course the answer is yes. So if you go to the graph and click on that positive symbol, and then select that arrow bar option, okay, and then go to that little triangle and choose among different things. Maybe you can choose percent error. Okay, so percent error option, then yes, it's going to show you the percent error showing up there. Okay, and then maybe you can play with the more options, to choose percent error. Do you want to have it show up on maybe y-axis percent error? Yeah, that's probably what it is. The front numbers obtained from 5 different plants. Okay, or do you want that from the x-axis as well? So you can play with that by playing with this error bar options. Okay, so choose a series of x error bars or y error bars. So y is what you want. Okay, so that will show up there if you click on that. Okay, so that's how you do it. Okay.